The brick walls lining your street are calculated structural equations. Every grid is a deliberate choice balancing gravity, weather, budget, and human endurance. For centuries, masons have perfected the technical precision required to assemble thousands of small, brittle rectangles into massive structures that won't collapse. This process relies on a basic geometric vocabulary. A single standard brick has two structurally useful sides: the long face, which bricklayers call a stretcher, and the short end, called a header. Stacking stretchers directly on top of each other creates a continuous vertical joint. Downward loads follow that straight seam, splitting the wall. But staggering bricks to overlap the seam changes the physics, forcing pressure safely sideways through the solid mass. This repeating, staggered pattern is called a bond. The specific way a builder decides to stagger these bricks dictates the entire structural and economic fate of the wall. When budget is constrained, builders use the rat trap bond, turning bricks on their edges to form a box-like arrangement. This hollow square center reduces required brick and mortar by 25%. The trapped air creates a thermal buffer, making it incredibly popular across hot climates. While the rat trap bond saves material, the English bond serves as the traditional standard for load-bearing mass. Strength is achieved by alternating rows, one course of stretchers followed by headers. Because headers span the entire wall's depth, they physically bridge the front face to the back. Conversely, modern stretcher bonds exclusively stack long outer faces, completely lacking backwards physical ties. Builders trade the English bond's mass for the stretcher bond's speed because a modern house's timber or steel frame handles the actual load-bearing bark. Some architects discard structural rules for aesthetics. The stack bond deliberately lines up continuous vertical joints into a minimalist grid. Breaking the overlapping rule leaves almost no structural integrity. To prevent cracking, crews must embed horizontal steel wire mesh into the mortar beds. However, even the most rigidly engineered bond fails to keep buildings dry if the mortar profile is finished incorrectly for the local climate. This comparison shows why that finish matters. On the left, a recessed raked joint creates a striking shadow line, but that small ledge traps water and causes frost damage. On the right, a smooth, concave profile seals the gap and sheds rain off the facade. The global shortage of skilled labor has reached a crisis point, driven by the career-ending physical wear and tear of manual bricklaying. Full autonomy offers one path forward. Machines like the Hadrian X use a truck-mounted boom arm to read 3D CAD models and place bricks using specialized adhesive instead of wet mortar. The SAM 100 provides a collaborative alternative. It moves along traditional scaffolding alongside a human mason, managing the heavy lifting and repetitive mortar application, while the human crew handles complex corners and quality control. Whether utilizing fully autonomous booms or collaborative track robots, the industry is engineering the physical failure of the human body out of the equation entirely. A brick wall is a highly specific architectural response to a site's budget, strength requirements, and available labor. Builders use the dense English bond for pure structural mass, the hollow rat trap bond to maximize insulation, and the stretcher bond for sheer speed on modern cosmetic veneers. These overlapping geometries allow you to read the hidden engineering, financial constraints, and historical era of a building just by looking at its facade, long before ever seeing a blueprint. The next time you walk past a brick wall, take a second look and see which patterns you can spot. And if you want to keep exploring the hidden engineering shaping our everyday world, hit subscribe.